Hello. Hello. My name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 790. Please turn to it. Page 790, and today is our lesson number 100. Let's take a look at it. It has two problems, number 19 and number 20. They are both hard problems. I'm going to start with number 20 first, and then after number 20 is finished, we'll do number 19. We're going to go in reverse order. Number 20. In number 20, we are given two graphs there. The original graph and the new graph on the right hand side. You have to have the book in front of you, otherwise none of these things is going to make any sense to you. You can't just sit there and listen to what I have to say. You have to have the book in front of you. You have to actively participate in it. Do the thing along with me. So as you turn to the page 790, and if you look at the two graphs there, you will see that we have two graphs there. The graph on the right hand side, as you can see, is the same graph as the original graph on the left hand side, but it has been shifted, it has been moved. And as a result, we have a new function. The question simply is, in the new function, this is the original function here, f of x, let's call it y, y equals f of x. This original function is called f. The name of the original function is f, and here's our new function, which is g of x, which is f of x plus h plus k. And the question simply is, how much is h times k? How much is h times k? Now here's what we're going to do. Instead of dealing with the graph that they actually give us in the problem, we're going to do the same problem except with a simpler function. Because the notion, the idea, the concept that applies in the simpler function is not going to change. It's the same idea, same notion, same concepts are going to apply to this graph. It's just that this graph is a little bit more complicated. But it doesn't change anything. The simpler graph will serve the purpose. So here's a simpler graph that I want you to look at, which is this graph right here. Y equals, again, our original graph, we're going to call it f of x, and that's simply x squared. Let's see what the equation of this graph looks like. A lot of you probably already know it, what this is. For example, here, when x is equal to 0, y is going to be 0. Because 0 squared is 0. Y equals x squared. When x is positive 1, y is 1. And when x is negative 1, y is still 1. Because y equals square of x. Therefore, when x is positive 1 or negative 1, the square of positive 1 or negative 1 is just 1. So y is 1 when x is equal to positive 1 or negative 1. Similarly, when x is equal to positive 2 or negative 2, y is going to be 4. Let's see what this graph looks like, shall we? We have 5 points already, that's plenty. So when x is 0, y is 0. Here's our first point. When x is positive 1 or negative 1, y is 1. When x is positive 2 or negative 2, y is 4. 1, 2, 3, and 4. Right here. We have 5 points, and that's plenty. So what do we have here? It's a simple ordinary parabola, nothing to it. It's a simple parabola sitting at the origin. Now here's what we're going to do with it. We're going to take our original graph, or original function rather. The name of the original function is f. F is just a name. Whenever a relationship is stated between the two variables, the relationship is usually given a name. And the name is the letter f. That's all it is. Why f? Because the word function begins with letter f. That's all it is. It's just a convention, it's just a tradition that we call our relationship between x and y, we call it f. Now if we have more than one relationship in the given problem, we cannot call it, we give it the same name, we cannot also call it f, we have to give it a new name. So traditionally again, conventional dictates that the second one is going to be called g, because g comes after f, that's all it is. If we had one more, the third relationship would have been called h, and then I, and then k, and so on and so forth. But it's just the name of the relationship. So the new relationship that we're going to have is y equals g of x. And that new relationship is this. X squared minus, let's see what they want us to do, minus 3. I want you to find out what the graph of this equation is going to look like. X squared minus 3. Watch what happens. Before, when x was 0, y was 0. Now, and when we say now, we're talking about this new relationship. Now, y is going to be 0 when x is, let's find out, shall we? We want this quantity to be 0. How can we make it 0? No, this is wrong. That's not what I meant to say. It's not x squared minus 3, it's my mistake. It is x minus 3. I just noticed it as we got to this stage. X minus 3 squared. That's what I meant to say. Okay? X squared minus 3 is something different. We'll come to that in a second. One thing at a time. Now, when y is going to be 0 when x is how much? X would have to be 3. Because you see, y equals x minus 3 whole squared. So now, when x is 3, 3 minus 3 is 0, and 0 squared is the value of y. So now, y is going to be 0 when x is 3. Let's plot it, shall we? When x is 3, y is 0. Here's our first point. Before, let's give these points name, okay? We're going to call this point A, and we're going to call this point small a. The small a. Now again, one more time. Before, when x was 1, y was 1. Now, y is going to be 1 when x is 3 more than before. What was x before? X was 1. X was 1 when y was 1 in the original function. X is 1 when y is 1. Now, x would have to be 3 more than that. X would have to be 4. As you can see again, 4 minus 3 is 1, and 1 squared gives us the value of y to be 1. The question is, why does x has to be 3 more at each point than before? In other words, the question is, for each given value of y, why does x has to be 3 more than before? Well, the reason is very simple. Because we're subtracting 3 from the x. Whatever the value of the x is, we're taking away 3. So to compensate for the fact that whatever the value of x is, we're going to take 3 away from it, x has to be 3 more than before. To make up for it. That's all. That's all. To compensate for the fact that the value of the x is whatever it is, we're going to subtract 3 from it. So the guy has to be 3 more than that. It's the same relationship between x and y as before. It's the exact same relationship. It's the exact same play. It's the exact same play, except everything is taking place 3 seconds later. X appears on the stage, does the same thing, speaks the same line, but he appears on the stage 3 seconds or 3 minutes later. But the play itself is the same. Do you understand? Nothing has changed. So now, when x is 4, y is going to be 1. Before, when x was negative 1, y was positive 1. Now, y is going to be 1 when x is, you see, before x had to be negative 1. Now it's going to be 3 more than that. Negative 1 and positive 3 is positive 2. And we can see that right here. Positive 2, x has to be 2. 2 minus 1 is negative 1. And negative 1 squared equals 1. So x is 2. 1, 1, 2, right here. So this point right here is point B, which is a small letter b here. This point right here is point C. This is a small letter c here. And here's our new parabola. Let me put it in a different color. And I should not have drawn so close to the end of it, because we have no room now, right here. What has happened? What has happened is that the entire parabola has been shifted 3 units to the right. It's the same parabola as before, except everything has been shifted by 3 units. From this capital letter A, which was the origin, to this small letter a, is a distance of 3. The same story is taking place, except the story takes place, every scene takes place 3 minutes later. That's all it is. So what do we learn from it? What we learn from it is this. Okay, watch. I need the room, so I need to erase it. That's it. We're done with this thing. What we learn from is that when we have a function, and a constant, some number is subtracted from it, it's a minus sign here. What that means is that this negative sign, this negative 3 tells us, this negative 3 tells us that the entire graph has been shifted to the right. Now it's very important that you understand the concept behind it. Don't memorize it. Because if you memorize it, you're going to get confused. Because it is counterintuitive. It is counterintuitive because ordinarily, traditionally, one would assume that if you're picking something up and moving it to the right, you're going up 3 units. And therefore, it should be plus 3. No, it is precisely because we are picking it up and moving it to the right 3 units that we have to take away 3. Because for each given value of y, x is going to be 3 more than before. And x cannot be 3 more than before. The value of the x has to be the same. The y is going to be 0 when x is 0. Because it's the same relationship as before. But except now, it's not the x that is 0, it is this quantity in this parenthesis that appears here has to be 0. This quantity has to be 0. Y is going to be 0 when this quantity in the parenthesis is 0. Well, how do we make this quantity in the parenthesis equal to 0? When x is 3. 3 minus 3 will give us 0. Otherwise, if you were to put plus here, it'll be 0 plus 3. It's going to be x will end up being 3. Do you understand? Y has to be 0. Y is going to be 0 when this quantity in the parenthesis is going to be 0. So it's been shifted to the right 3 units. Now what I want you to do now is look at the graph that they give us. Okay, the graph on the left hand side, and notice I want you to redraw this graph 3 units to the right. Just do that, 3 units to the right, and you will see that that's exactly what it is. It's been 3 units to the right. First it shifted 3 units to the right, and then they move it up and down a little bit. We haven't done that part yet. So here, this part that we're looking at, this negative 3 that we're looking at here, is this part right here. It's the same value, the relationship is the same, except it has been shifted, the graph has been shifted 3 units to the right, which means our h value here, h equals negative 3. H equals negative 3. Because of the fact that we can clearly see that the graph has been shifted 3 units to the right. Whenever the graph is shifted to the right by 3 units, it will show up as negative 3. If you shift it by 5 units, it will show up as negative 5 in the relationship. Now let's talk about the movement along the y-axis. Now movement along the y-axis is simpler and easier to understand. Here's movement along the y-axis is very simple. Let's erase all of this thing. So here's the original graph, f of x, which is x squared. We're not dealing with the equation that they give us. We're not dealing with that graph. We're dealing with this graph here. F of x equals x squared. Now what's going to happen if we write a new equation, new relationship, g of x equals x squared minus, you see they're shifting it down. If you look at the graph, it's been shifted down. The question is how many units has been shifted down. If you look at the peak, again, just listen to me and follow it. Look at the graph on the left hand side and you will see that the peak appears at negative 1 and 3. The peak in the new graph that you see there appears at 2 and 1. Going from negative 1 to 2, is a shift of 3 units along x-axis. That's what that part shows you. Now we are interested in from 3 to 1. From 3 to 1 is a drop of 2 units. And that's your movements and that's the moment along y-axis, and that's what they're calling k. K equals, because it's going down from 3 to 1, because it's going down, it is -2. And we're going to understand it here as to why it is. That's it. From 3 to 1, this part right here, if you look at the peak, it tells us that it's been dropped down, it has been shifted down along the y-axis by 2 units. And I needed to know that because that's exactly what we're going to do here. Watch what happens. So let's subtract 2 from it. Now listen to me, I'm just going to make a quick comment here. Technically speaking and strictly speaking, I should not be doing this thing what I just did here, because I cannot call this graph, this function g, because the function that we called g before was this function g, what we called was x minus 3 squared. That's what we call g. So I cannot call it g. I have to give it some new name. I cannot give it the same name. That will not be proper, that will not be legal. That's a new relationship between x and y. This relationship between x and y, original relationship between x and y was y equals x squared. This new relationship was, new version was y equals x minus 3 whole squared, which we saw it meant that we pick up the original parabola and shift it 3 units to the right. Now we are taking the same original graph, same original parabola, and we're going to shift it down by 2 units. You will see that this -2 means that we're going to shift it down by 2 units. But this is a different relationship than that one. I cannot call it the g. We have to call it something else. We have to give it a new name. F, G, H. Let's call this H. Okay? Let's see what it looks like. So here's the relationship. Here's the value of x. Here's the value of x. Here's our old value of y. And here's the new value of y. Based on this relationship. Before, when x was 0, y was 0. Now, when x is 0, watch what happens. When x is 0, 0 squared is 0, 0 squared minus 2, y is going to be 2. Before, when x was 1, y was 1. Now, when you put 1 here, 1 squared is 1, 1 minus 2 is -1. Before, when x was 2, y was 4. Now, when you put 4 in here, 4 squared is 2 squared is 4, 4 minus 2 is 2. As you can see, the value of y for each given value of x, for each given value of x, the value of y is 2 less. It is 2 less than before. It's the same relationship between x and y, except y is just 2 less than before for each point. For any point that you take, y is 2 less than before. So here's our original graph here. Our original graph looks something like this. When x was 0, y was 0. Now when x is 0, y is going to be -2. Before, when x was 1, y was 1. Now, when x is 1, y is going to be -1. You see? From 1 to 0 is 1, and then from 0 to -1 is another one. So it's 2 less. Before, when x was -1, y was 1. Now, when x is -1, y is going to be -1. So we go from this point to that point. And here's our new graph. It's the exact same parabola, exact same shape, except it's been shifted down by 3 units. By 2 units rather. That's exactly what's going on with the graph that they give us on the right hand side. If you look at it, if you picture it, draw it, take the original graph that they show you, first shift it 3 units to the right, and then once you have shifted it 3 units to the right, that's the first part, that's the first half of the story, and then take that part, which is what I'm calling g of x. I erased it. Our g of x was, this is h of x, our g of x was x minus 3 whole squared. So this is the original story, then we go to this stage, then we go to this stage. So this is the original graph. One is the original graph. So we take our original graph, we shift it 3 units to the right, which shows up as a -3 here, which is the value of h, and then once we have done that, we shift it down by 2 units, and you will see that you will end up with the same exact graph that you had in the beginning, except located in a new location. It's been shifted 3 units to the right, 2 units to the bottom. That's all it is. So here, having said all of this thing, what we learn here is that here the value of h is -3. It's -3 because it's been shifting to the right. I'm repeating it one more time, probably for the 5th or 6th time, just to make sure that you understand that shifting along the x-axis is the confusing part. When you're shifting a graph along the x-axis, that's where the counterintuitive part comes into it. That's where it is counterintuitive. So when you shift it to the right, it shows up as a -3. When you shift it to the left, it would have shown up as a +3. But moving along y-axis is quite intuitive. It's exactly like you would expect. The value of y will go up by 2 units, so it will shift up by 2 units. If the value of y at each point, if the value of y goes down by 5 units, you will shift it down by 5 units. So movement along the y-axis is very simple to remember. It's the x-axis that you have to be careful about. So because here we are taking our graph and shifting it down by 2 units along y-axis, therefore the value of k is -2. And the question was, how much is h times k? The answer is h times k is -3 times -2, which is +6. The answer is +6, which is E. That's it. That was a very long explanation as to what's going on here. Now, as always, I could have just very easily have stood here and simply tell you that this is the value of h and this is the value of k, and therefore the answer is 6. But you wouldn't have gotten anything out of it. Do you understand? As I always remind you, we are not here for the sake of solving a problem. We are here for learning. There's a big difference. Do you understand? I don't want you to come over here to watch somebody simply solve a problem sitting there passively. I want you to learn. I want you to take an active part in it. Let's do number 19. Enough said. Let's do number 19. Now typically at this point in the story I usually have a sip of my tea. I just realized that I left my cup upstairs, so I can enjoy my tea. I'll give you 5 seconds just as a break. Number 19. Number 19 deals with the concept of exponents. All they want to see here is if you know how to manipulate your exponent. That's all it is. We are told that x equals x raised to -4/3 equals k to the -2nd. We are also told that y raised to 4/3 is equal to n squared. The question is, how much is x times y raised to -2/3? Well, first thing first. Let's keep it separate. You see, for example, here, if we are told that a raised to -2 is same as b raised to -3, then that also implies that a raised to 2 must equal b raised to 3. Why? Because basically we're taking this relationship between a squared equals b cubed and multiplying the exponents of this pi by -1 and this multiplying the exponent of this one by -1, which is perfectly legitimate. And if you do that, it will end up in -2 and -3. So this implies that x to the 4/3, that's the first part we have to understand. This implies that x to the 4/3 must equal k squared. Now here's the second part that we have to understand. Here we have x to the 4/3 and here we have y to the 4/3. Well, if x to the 4/3 is k squared and y to the 4/3 is n squared, then x to the 4/3 times y to the 4/3 must equal k squared minus n squared. This quantity equals k squared minus n squared. Okay, let's keep on going. Keep on going. Let's take the square root of both sides. Let's take the square root of both sides. So here, square root of x to the 4/3 is same as x raised to 4/3 times the 1/2. And 4 is going to cancel out with the 2 and we end up with 2/3. So this is x to the 2/3 and this is y to the 2/3. And what's the square root of k squared and n squared? Square root of k squared times n squared is just k times n. We're almost done. And now the question is not how much, which of course this can be written as x times y raised to 2/3 equals k to the n. But the question is not how much is x times y raised to 2/3. The question is how much is x times y raised to negative 2/3, which is very simple. Multiply the exponent of this guy by -1. And multiply the exponent of this guy by -1. That's it. So the answer is x raised to negative 2/3 equals k raised to n raised to -1. Is that how they leave it, or do something which can be written as 1 over k times n. 1 over k times n, and that is answer choice A. Now here I am actually simply solving the problem, because for me to stand here and teach you how to manipulate the exponent, it's not something I can do it in the video in a few minutes. You really have to know how to manipulate your exponents, and if you're not good at it, then you're going to have to simply skip this problem. That's the reality of it. You understand? Because I cannot actually possibly, as I said, we cannot actually learn how to do the exponents in just a short clip here. So I showed you the basic steps that you need to know, and you will understand it, and you will get something out of it as long as you have the foundation behind it. But if you don't, then you will have to skip it. All right? That was the end of this section. I will see you tomorrow, where we'll begin section number 9, the very last section in this exam. All right? Bye now.